Okay, we're going to look at number 6 in section 2.4. This problem says to determine the point at which the function, and again, this function should be something similar to what you have, is discontinuous. Then we're going to state the type of discontinuity. I'll explain that. There's actually a multiple choice selection for that in the problem. And then whether the function is left or right continuous. That's also a multiple choice part. So first of all, the question is, where is this function discontinuous? Excuse me, where is it continuous? It's continuous on its domain. And so any value that's not in the domain of the function, right, will make it discontinuous. Since these are composed of just our basic functions, right, polynomial functions divided by each other, rational functions, they are always continuous on their domain. So the question really is, what is the domain of this function? And any value not in the domain, then we're going to be discontinuous. And so let's see, what is this going to, when will we have troubles with this expression? Well, obviously when we divide by 0, right? Division by 0, because I can add anything, to a number. That's not a problem. I can multiply a number by 5 and subtract 3. I'm always going to get a number. But when I divide, if I divide by 0, that's a problem. So when is 5x minus 3 equal to 0? That's the question. And that's true when x is 3/5. And so the point of discontinuity is at x equal 3/5. Okay. Now, what type of discontinuity is this? And are we left or right continuous at that point, even though it's not continuous? Well, to determine left or right continuity, we'll take the limit from the right here. Limit is, we approach 3/5 from the positive side or from the right of this expression. So what does this look like? The top, is approaching what? 3/5 plus 1. It's approaching 8/5. 3/5 plus 5/5 is 8/5. The bottom we know goes to 0, right? But the important thing is, since we're approaching 3/5 from above, right? This is something above 3/5 or 0.6. So if I plug in anything above 3/5 into this expression, it's small, but it's, as I'm getting closer and closer to 3/5, it's small, but it's always positive, right? 5x minus 3 will always be positive if I plug in anything slightly bigger than 3/5. So I say it's approaching 0, but it's always positive. So positive divided by positive is positive, and 8/5 divided by something going to 0 is blowing up. It's going to positive infinity. So notice we have a vertical asymptote, and that tells us that we have an infinite discontinuity. Okay, there's some other choices there of removable discontinuity. Removable discontinuity, I'll just say, is where you have like a hole in the graph. So the limit from the left and limit from the right both exist and are equal. In other words, the limit exists, but the value of the function might be, somewhere down here, right? And so it's removable in the sense, if I just redefine the value of the function, I can fix things and kind of plug that point into the hole, so to speak. This would be a removable discontinuity. A jump discontinuity is where we have, maybe the limit from the left is approaching this value, but then the limit from the right is this value. We might have one of these filled in, maybe this point is filled in, or maybe the point somewhere else, but this is a jump discontinuity. We have a break. The limit from the right and left both exist but are not equal. So removable, jump discontinuity are the other two. Infinite discontinuity is basically just a vertical asymptote. If we look at the limit as we approach 3/5 from the negative side, the same thing happens. Up top we get 8/5. The bottom we're getting 0 again, but this time, since we're approaching for values less than 3/5, this difference 5x minus 3 is now negative always. So a positive divided by a negative means this expression is going to negative infinity. Basically the graph of this function looks something like at 3/5. All right, we have a vertical asymptote. I'll just do that as a dashed line. And as we're approaching 3/5 from the positive side, we're going to positive infinity. As we approach 3/5 from the negative side, we're going to negative infinity. So that's basically what the graph's behavior is there. So yeah, infinite discontinuity, it is neither right continuous nor left continuous. Okay, so again, right continuous would have to be what? The limit from the right is equal to the value of the function at that point. And, the limit clearly does not exist, right? Even though it's infinite, this is clearly, the limit does not exist. When we say we don't use DNE in this case because we use the symbol infinity or minus infinity to indicate the behavior of the function, but the limit still does not exist as a finite number, which has to be true in order for us to be right continuous or left continuous. Okay, I hope this one makes sense on this. If not, please let me know.